Pat tonight's going to be talking about the Collins 310B exciter. And I think it's just my affinity for World War One and Two stories that gets me a little bit interested in amateur radio back in those days. So, Pat, I am really looking forward to this, and I hope everyone else is too.
Hey, well, thank you, Jean Ann. And I hope I can live up to your expectations for some exciting World War II comment. So I'm going to talk about some old Collins gear once again. And in addition to the 310B that Jean Ann mentioned, I'm going to talk about a couple other similar radios. And while I'm going through this, if anybody has a question, just feel free to ask. You don't have to wait till the end, though we probably won't have any lengthy discussions or anything, but we can certainly answer questions as we're going through. Okay, so the Collins 310X series, what I like to call the age of the exciter. So World War II ended in August of 1945. And with the war over, all of the radio manufacturers rushed to switch back to producing civilian radio equipment as rapidly as they could. What most of the suppliers put out were really their pre-war offerings, and Collins was actually no exception. Collins' first offering that they started advertising in September of 1945 was a transmitter from 1939. However, they followed up very quickly with the 75A receiver and the 32V1 transmitter, both in October and November of 1946. So they must have been pretty well ready to go. This transmitter and this receiver were very popular. The 75A series ended up with the 75A 1, 2, 3, and 4. Many thousands of units sold. The 32V transmitters were the 32V1, 2, and 3, and quite a lot of those sold. So these are still very common. Hams today are very likely to recognize this. They're easy to find. You can go on eBay any day, and you'll find a number of them for sale. It's getting harder to find good quality, especially in original condition, because these are just about 80 years old now. But these were very popular and very well known to hams. At that same time, Collins also put out a line of exciters. And those are not as well known at all. And in fact, if you're not a collector of Collins gear, you probably have never heard of these or seen these. And I've even run into a number of Collins collectors that are unfamiliar with these. And what Collins came out with was the 310A, B, and C, and each one of those was available in several variations. Now, when you take a look at them here, you might think, well, they actually look kind of similar. Well, you're right, they do look kind of similar, but they're very different internally, and they have some different functions. And so we'll talk about that. One of the things that they have in common, though, is their PTO. I should probably explain what is an exciter. I'm not sure we use that term an awful lot these days, but when your transmitter is hooked up to the antenna, it's a transmitter. When it's hooked up to a higher powered amplifier, then it's an exciter. And I don't know where that definition started, but it goes back pretty far. And here's an excerpt from a radio handbook from 1946 explaining that sometimes your rig is an exciter and sometimes it's a transmitter. Collins' big innovation was the permeability tuned oscillator. Standard radio equipment produced by almost all manufacturers changes frequency by using a variable capacitor. Collins switched to having a variable inductor, and they came up with a very innovative design. It's called this particular one is the 70E-8 permeability tuned oscillator. And in the picture on the left there, that aluminum looking collection in the middle of the picture, that's the permeability tuned oscillator. That aluminum can sticking up towards the top of that is a tube shield. That glass thing in the middle is actually a silica gel desiccant capsule that screws into the PTO. And then it's adjusted from the front with a standard looking dial. These PTOs were extremely stable. They had a pretty good resistance to changes in line voltage and were very stable with temperature, and also were very stable over long periods of time. And they were generally accurate enough that you could calibrate your radio at the base operating frequency, which in this case is 80 meters, and you could easily be within 1/2 of a kilohertz, or 500 hertz, which doesn't sound like much today, but in the World War II era was pretty much completely unheard of. You could turn one of these on, and within a few seconds, it's stable and right on frequency. And interestingly, Collins sold these PTOs as a component part for a while, where you could buy one of these and you could build your own exciter. And that's what the Collins advertisement is showing here. This person built his own VFO to run his high-powered transmitter. Something you're going to hear me say several times this evening is that this is kind of pricey. It's, I think, another enduring characteristic of Collins gear is that they tend to be pretty pricey, but I guess it's one of those things, you get what you pay for. So the 70E-8 PTO in 1948 sold for $40, which is just over $500 in today's money. So this is not an inexpensive proposition to get this level of stability and frequency control. And because you could build your own, there were a number of projects that got published, and this is from some projects that were from the Radio Handbook of 1949. I should also point out that these PTOs were not for sale for a long period of time. Collins only offered them for a couple of years, and they stopped. Then they reissued them in the early 1950s. But they sold enough of them, apparently, that it made it into the popular handbook of the time. And as you'll see, and as we look at some of the other radios, the Collins PTO is right in the middle. It's always in the middle on these things. You can see the slide rule dial from the front, and you can see the PTO assembly from the back. And these really end up looking a lot like the other Collins exciters. So kind of an interesting concept, and resulted in some very interesting projects. So the first exciter that Collins came out with was the 310A, and this was available in several different iterations. The 310A was paired up with the Collins 30K transmitter. And in this Collins ad, the 30K transmitter is that box on the right-hand side. These are a 6-foot tall black box radio, weighs about 300 pounds. I've got one of these. I do not have the 310A though. This is the big iron that people talk about. As far as I can tell, the 310A was not sold separately from the 30K, and the 310A had quite a bit of circuitry inside of it. In fact, it could either be used as a transmitter with a 10-watt output, or it could be used as a VFO to power the 30K transmitter. And the pair was pretty pricey. So the 310A exciter and the 30K transmitter sold for $1,450 in 1948, which is just under $20,000 in today's dollars. The 30K transmitter, there were only about 100 of them produced, and today there's about 50 that are known to exist. I have no idea how many 310As there are. I have never seen one, and I've never seen one offered for sale. But they were the inspiration, I guess, from Colin's standpoint, for the other exciters that they came out with. In fact, one of the Collins ads says that the 310A, they were so pleased with it, they thought they could, with some modifications, turn it into a dandy little transmitter that would be great for the beginner or as a backup transmitter for the experienced ham. So the next offering was the Collins 310B. So this is kind of a reworked 310A, though the circuitry is completely different, but the concept is very much the same, and they look kind of the same. The 310B could be used either as the VFO to control the higher power transmitter, or you could use it as a low power transmitter. And it has about 35, 40 watts input, so you get around 15 watts out. The approach Collins took to frequency control here is this, of course, uses the 70E-8 PTO, like all the other Collins exciters. And the buffer multiplier stages, and there's 3 of them, are band switched. But the final amplifier stage requires a plug-in coil. And you can see some plug-in coils at the top. So you could set your band that you wanted to use from the front panel very conveniently, but you had to reach into the radio and switch in the proper coil for the band that you wanted to operate on. Kind of inconvenient, I think, but probably more convenient than having to plug in multiple coils for band changes, which was kind of the practice in the years leading up to World War II and for a few years after. For example, a similar product, the Meissner signal shifter, had 3 coils per band. So if you wanted to be on 80 meters, you plugged in 3 80-meter coils. If you wanted to be on 20 meters, you took those out and you plugged in 3 20-meter coils. So I guess if you look at it that way, having to only change 1 coil, that's probably better than having to change 3. Inconvenient or not. And these were also pretty pricey, right around $200 in 1948, which puts it at about $2,500 to $2,800 in today's money. So these were a significant investment for a low power transmitter. Now, you note that we've got the 310B1 and 3, and I'll talk a little bit about the differences between them. They're not real big differences, but they are different. So this is a 310B-1. So the -1 has a link coupled output that's used to drive a high-powered amplifier tube. So you can't do any adjustment to the transmitter circuit besides dipping the final. The output current and the output power depends then on the load that you apply. Because this actually puts out about 15 watts, you could connect this link coupled output to an antenna tuner and use it to drive an antenna. And I'm sure some people did that. But this one was intended to be operated with a high-powered amplifier. Picture on the lower left, if you open up the lid and you look inside, you'll see 3 different sections. So the center section, that kind of orangish yellow looking thing, that's the permeability tuned oscillator. On the right-hand side, you'll see the power supply and the voltage regulator tubes, the transformers and that. The left-hand side is the buffer multiplier and final amplifier. If you look at switch to the photo on the right-hand side, you'll see those 3 black metal tubes. Those are 6AG7s. Each one functions either as a buffer stage or a multiplier, depending on what band you're on. The glass tube is a 2E26, which is kind of a little brother of the 6146 tubes, which 6146s were used in an awful lot of ham equipment. And then just to the left of the 2E26, you'll see an empty socket, and that socket is where the coil gets plugged in when you're changing bands. Then the upper left-hand picture is just a view of the underside of the chassis, so you can see that there's quite a lot of parts in there. The RF section is on the right-hand side, and we'll look at the RF section on one of the other 310Bs, and you can see some of the differences there. Now, the 310B-3 is identical to the 310B-1, except that it has a built-in antenna tuner or built-in transmatch. And that's those two knobs that you see in the upper left-hand corner. Those are used just like you'd use any antenna tuner. You dip the plate. You then use these tuning controls to increase loading to load up to the current you want, and you're ready to go. And you could either have this hooked up to your antenna, or you could connect this to your amplifier stage and use these controls to match the impedance, match to the grid impedance. So kind of a versatile little rig. And this has got 15 watts output, just like the other one. The 310B, and this is my 310B, or one of my 310Bs. These were modified at some point too, and I'll explain a little bit about that modification. So the picture on the left here shows the antenna tuner, and that's that variable capacitor and that switch that's mounted, and you can see them in that red box. Now, remember I said this was identical to the other one? Well, you can see at a glance here, it's clearly not identical. So this one has been modified, and this has been modified to reduce television interference. So there's some shielding that's been added inside. And that shielding is the perforated metal cabinet built around the RF section. There was another further modification that involves those ceramic coil forms that you can see in there too. And we'll talk about that in just a minute. In 1953, a guy named Bill Orr, W9JI, wrote up a very interesting article on the Collins 310B. Bill Orr was a very popular author in the mid-20th century, wrote articles for CQ and for QST. Some of his QST articles are really funny. He wrote some, not just technical articles, but he wrote some very interesting bits of entertainment too. Very funny guy. In this article that appeared in CQ magazine, Bill Orr relates how he took his Collins 310B on a DX vacation and worked something like almost 1,000 contacts, I think 950 contacts in 45 countries using this little rig. But when he came home and tried using it, he found that it overloaded any television receiver within a couple of 100 feet of his house. So something had to be done. And he goes and explains in some pretty good detail here how he went about figuring out what was wrong and then what changes he made. In the late 1940s, television was becoming very popular, and television interference became a very big deal for ham radio operators. Very little attention was paid to harmonic content of transmitter waveforms, or to spectral purity in general. Shielding was generally not that great. So television receivers were very sensitive, and especially if you lived in a fringe area, your transmitter was very likely to cause interference with either your own or with your neighbor's television. Now, there's kind of a standard protocol for reducing television interference that's pretty straightforward, and that's to add some bypass capacitors and filtering, add some shielding. The shielding in this case was to take copper window screen and solder it over the openings in the cabinet. Bill Orr, though, incorporated another change in here that had nothing to do with TVI, and that's the addition of that collection of coils, or that turret of coils you can see in the photos here. This was an assembly made by Barker and Williamson. that you could buy to put into any low power transmitter as a final amplifier, like kind of a ready to go final amplifier coil set. And what he was able to do with this is to eliminate the need for that plug-in coil. So now you've got a completely band switched rig that has no television interference. So pretty nice innovation. And here's a look at the way that those modifications were done in my 310B. In the picture on the left, you can see those ceramic coil forms down inside the RF cage. Those were added, and that eliminates the need for the plug-in coils. And then on the right-hand side, the right-hand picture, if you see where the red box is up here, you'll see these two white sections. These are additions that are made to the band switch. So this whole assembly right here, I'm running the mouse over it. This is the band switch assembly. So in order to use the band switch to change bands with these new coils, he had to add two switch sections. Now, if you've ever worked on one of these radios, anytime you have to mess with a band switch, it's usually difficult to do. They're hard to work on. There's very little room. If you have to take one out, there's a lot of connections that have to be taken apart. It can be really difficult. So this is kind of a clever addition to extend the length of the band switch to include a couple extra sections that allow you to do this. So this was a pretty major modification of this transmitter. I've never seen any other one modified like this. I know I've seen the article, and there was some speculation that at one point Collins might have sold a kit that did this. But as far as I can tell, there were very, very few of these radios that were actually modified in this way. I like using this radio. This is one of my favorite CW rigs, so it turned out good. The final exciter in the 310 series is the Collins 310C, which was available in two versions, one with an external power supply and the other with an internal power supply. Now, Collins, of course, called this an exciter. I think today we would just call this a VFO. This is a very simple rig compared to the others. It's an 80-meter VFO. It puts out a signal from 3.2 to 4 megahertz. Puts out about 200 milliwatts or so, depending on the load load impedance, and has just a few tubes inside of it. But of course has that 70 E-8 PTO. And with this, you would just hook this up to your transmitter in place of a crystal and use it like a VFO. Now, I said the output runs from 3.2 to 4 megahertz, but if you look at the dial, you'll see that this is calibrated from not just the 80-meter band, but 80 through 10, and includes even like kind of a vernier dial above the main tuning. One of the ways you would use this is you would take your 80-meter signal into the transmitter, and then you would multiply, your transmitter would multiply that signal up to the frequency you want it to operate on. So if you said, okay, well, I've got my 80-meter VFO and I want to operate on 28.56 megahertz, where do I set the VFO? So you don't have to kind of go through that mental gymnastics of trying to figure out where do I set the VFO to multiply up. Collins had this all figured out for you, and they had the bands all laid out, and the calibrations were pretty good. So you could just tune right to the frequency you wanted, and you'd likely to be pretty close. And again, these were kind of pricey. The two different versions were both around $100. The one with the power supply built in was a little more, right at $100. The one with the external supply was a little less, which puts them at just over $1,000 in today's currency. These are much simpler inside than the other ones. There's really just the permeability tuned oscillator, which is in the middle in both pictures. In the picture on the left side, the two tubes on the far left of the transmitter or the far left of the VFO, those are the voltage regulator tubes. And the tube to the right, that black tube, is a buffer for the PTO. That circuit board is something I added, and that circuit board is used to turn on a signal that helps you to locate the VFO signal in your receiver when you're getting the transmitter set up. And if you read the newsletter this month, I had a write-up on that and explained about it in some more detail. Collins' claim to fame with their permeability tuned oscillators was their stability. And also to an extent their repeatability. So you could turn this on, and after a few seconds warm up, it was pretty steady on frequency and would stay on that frequency for a very long period of time. You could turn the radio off, you could turn it back on, and you would be back on the same frequency, plus or minus a few hertz. So the graph here is the frequency stability of my Collins 310C VFO. So on the graph, the y-axis, the vertical graph on the left side, that's in units of hertz, and the x-axis is in minutes. So this shows the frequency change over about a 4-hour period or so. So the maximum change in frequency that I observed, and the way I did this is I just hooked this up to my frequency counter and kept track of what the readings were over time. There was an 82 hertz variation over this time period from a cold start. And since the VFO was set for right about 3.5 megahertz, this is approximately 0.002% change, or about 20 parts per million. There's some Collins advertisements that talk about stability of their PTOs, and they claim that the stability would be about 0.003% change over a 24-hour period, which is about 30 ppm. So you can see this one, even though it's 80 years old and looks to be pretty well used, still it has its stability in the right range, at least over a 4-hour period. So pretty good for an 80-year-old radio. Now, if you say, okay, kind of interesting, but I don't really want to mess with all that tube stuff if I was going to wanted to play around with some radio equipment. So if you want the modern approach, WA1FFL, Jim Haggerty has developed a direct digitally synthesized VFO that is adaptable to use with any vintage radio or modern radio. So he put together a kit, and you can get this kit, and he'll work with you to configure the display, the digital display, to match up with the kind of radio you want to use. So in some cases you might want just to directly read the frequency. In this particular case, this one was put together for a KWS1. The VFO frequency doesn't really change, but the displayed frequency will change, if that makes sense. This particular one was built by Chuck, W9KR, who many of you know. And Chuck built this for his Collins KWS1. So it's kind of an interesting approach. These are extremely stable and have very high spectral purity. I would say it is the modern version of that old permeability tuned oscillator that Collins came up with. So just one little detail that might be of interest to those of you that are collectors of this kind of equipment. The 310B1 and the 310B3 actually had the same front panel. And to fit that antenna tuner in, there was this little plate on there. So if you had the one that had the link coupled output, the plate was on. But if you had the one where the antenna tuner was built in, you'd take that little plate off, or Collins would take that little plate off, and they could build that that control right in. So that's all I have on this. Does anybody have any questions? You have to unmute yourself.
If you go back to where you had the chassis picture, it seemed like you had added a fan somewhere. Is that correct?
Yeah. Let me go back to that, Bill. Hang on.
I also have a question.
Okay.
Where would you apply modulation for AM transmitting? In the power amp, or can the exciter do that?
It would be in the power amp.
Okay. So it just generates a carrier for the rest of the system.
Yes. The typical arrangement for an AM transmitter would be that the modulator is in series with the feed for the plate current or the high voltage. So your modulation transformer would be in series with the high voltage lead going to the highest power amplifier stage, and that would give you your high level plate modulation. There are other modulation schemes. You might also have, say, screen grid modulation, and there were various other ones that were developed over the years. But I don't think there's any scheme that involved modulating the oscillator stage. Not that I recall, anyways. Okay, so Bill's question was that a fan in there? So yes, there is a fan in there. This is the
Triggered by
inside.
stability, or what were you looking for there?
I'm looking to cool off the transformer, the power transformer.
Oh, okay.
So in the late 1960s or so, something called silica steel became commonly used in
Right.
transformers, and it reduced eddy currents. Eddy currents are caused by the switching fields inside, or the changing fields inside the transformer. They induce currents in the steel, and it causes them to get hot. And these old transformers tend to run smoking hot. This one, it runs probably right about 50 degrees C, 45, 50 degrees C. So I put a fan in there just to cool it off. These are not robust like modern transformers. These use an organic varnish to insulate, and they have there's paper insulation in here called fish paper, which is like a heavy cardboard. The leads are rubber and cloth insulated, so it just isn't good with high temperatures. It tends to cause breakdowns. So I try to keep it as cool as possible by putting the fan in.
Okay. Thank you.
Pat,
I
you
have a
mentioned
comment?
that there's a dual capacitor. What is that splitting the power to?
Not sure I understand your question, Brian.
I think he means that it was, you see right there, we have antenna tuner.
Yes.
I think he's talking about not understanding those aren't two different, those are really two different stages, are they not?
Yeah. So this would be a part of something called a pi network. So I'll use my mouse here. Hopefully you guys can see it.
Right.
This would be one of the capacitors in the pi network, and I'm sorry, I don't have a picture of a pi network handy here. But you would have one of these capacitors would go to ground. They would be at the input to the coil network, and the other set of capacitors here, would be at the output. So this device right here, this is actually a switch, and then these brown square things are mica capacitors. So they're not variable, but you've got a stack of mica capacitors, and you use this coupling control here to switch between different capacitors. And this is just a two-section variable capacitor. So by turning the knob on the front panel, you rotate this capacitor. Rotating it varies the capacitance. That changing capacitance then adjusts the network to match the final amplifier tube impedance to the antenna impedance. So does that answer your question?
Yes, sir.
Okay.
I deal with dual capacitors in heating and air conditioning, so I just wanted to make the association there.
Okay.
I have a question, Pat.
Go ahead, Bill.
You mentioned you have a 30K transmitter.
Yes.
Does it work?
No.
What does it have for finals in it? I saw in the article it was 375 watts out. Seems like an awful lot of cabinet for only 375 watts.
Well, and that's an interesting interesting observation because if you are familiar with any pre-World War II equipment that runs any amount of power, they tend to be in gigantic cabinets, and the 30K was no exception. And a later radio that Collins would come out with, the KW1, was another kilowatt rig. And here's the go back to the picture of the 30K. That was also in one of these giant cabinets. Now, if you would look inside of this, you would see that this is actually full of radio equipment. There's not a lot of unused space inside. At the very bottom of the cabinet, there's a power transformer, and the power transformer weighs about 150 pounds. And then there's layers of equipment as you go up through the cabinet. There's several power supplies. There's a modulator. There's a driver, and then there's the very top section is the RF deck, which is massive. The tube itself isn't very big. I think this uses either a 4-250 or a 4-100. I don't remember what the tube is.
I think it's 4-250, Pat.
4-250.
Now that looks, if I'm looking through the window, that's about the size of the tube. That's about the size of a 250.
So the tube itself is not physically very big, but it takes a lot of radio and to with the technology that they had at the time. And in fact, when I talked about the 32V1 transmitter, this was a big innovation on Collins' part in that this fit on your desktop, and this is 250 watts input on CW, and I think about 150 or so. About 150 watts input on phone. So this is considered a medium power transmitter, and it fit on your desktop. Now these weigh about 80, 90 pounds. I just moved one the other day. But getting one to fit into this package, which is about the same size as a receiver, that was a big engineering feat for Collins. So as a good selling point, you didn't need an entire tabletop or a gigantic rack of equipment now to generate a reasonable power output. It was heavy. It was hard to move. The main thing that I find with this tabletop transmitter approach, these are really, really hard to work on. They are so crammed full inside. If you have to work on anything, you have to disassemble a good amount of the radio. But they're rugged, they're reliable, they were very popular. And they were, for the time, they were the most compact medium power transmitter you could buy.
Pat, if you leave that picture there a minute, for those of you that look at that, if you look at that pair, let's just say roughly 200 watts input. It's a little more on CW, a little less on phone. And then the receiver, you're thinking the transmitter is about 80 pounds. The receiver is probably close to that, is it not?
The receiver is lighter. I don't know what it weighs, maybe 50 pounds.
Okay, so think about that. And compare that with the same power station that's an ICOM 7300 that weighs around 10 pounds. And its power supply probably weighs 4 or 5 pounds. So that's where it's come. When you think in terms of 200 watts, you think of the ICOM 753 or 7300, but you don't think in terms of what it was in the 1950s.
Yeah, and I think the other just really interesting point is this was considered a very compact station.
Right.
So this was, in fact, one of the Collins ads for this transmitter says you can take it with you, meaning, kind of a pun, I guess, or kind of a joke on from Colin's standpoint, but meaning that if you wanted to operate portable, you could pick this up and take it with you, which would have been probably impractical with something like a 30K or, or anything in a 6 foot tall cabinet that weighs hundreds and hundreds of pounds.
So no mobile installation?
These probably could be mobile, but
I bet somebody did.
Like in a van?
if you had a big dynamotor to generate the power, yeah, or you could haul a generator with you.
Well, you can take the heater out because you wouldn't need that anymore.
I bet those capacitors would make fine crystal radio capacitors.
Well, perhaps many years from now, when these are going to the recycling bin, that you'd be able to intercept them, Stan, and make some nice crystal radios out of them.
I have a comment.
Yeah, go ahead.
Just wanted to put your prices into even more of a perspective. And that is, if I were to have purchased a 30K back in 1946, that I believe you had the price of what, 1,700, 1,400?
Let me go find it again.
Well, I just jumped on the web, and in 1946, you could buy a home for just over 5,000. So this gear is enormously expensive, but still way cool.
Yeah, the buying power of I guess the combination of cost and technology and performance. This thing, $18,995 and $25, really expensive. It probably speaks to why there was only about 100 of them made.
Right.
Who's going to buy them? Who's going to buy a radio this expensive? But if you look at the modern version, the direct digital VFO, this kit plus switches and knobs and a case to put it in goes for between $200 and $300. So you get stability and performance and such in a VFO at about, say, half the price or less than you would get with this one. And you get superior performance. So that's, one of the other things as time goes by, I think we get more for our money in performance of our radio equipment, for sure.
Wasn't Collins considered like top of the line, absolute best you could get?
I think that would be the opinion that most people would have, that this was the best engineered radio equipment you could get.
When I was a ham, got my license in 1964, we had a large group of hams in our community. And I think only one of those hams had Collins equipment. That would have been the time of the S-line. So it was always been rather rare, rather unique group of people that were able to afford it. It would have been much better then than it would have been in comparison to the era that Pat's talking about, would be even more expensive.
Say, Pat, have you attempted to repair one of these PTOs? Have you taken them apart? I'm a little confused as to what's inside.
I was looking for a good picture, Fred, and I could not find one. Have I ever taken one apart? No, I have never seen one fail, and I've never had one that needed adjustment. So I've never had a reason to take one apart. What is inside of here, though, is first off, is a big ferrite core that has a nonlinear winding. And The nonlinear winding is to give you linear frequency change. So as you are turning the tuning dial, there's actually a slug moving in and out of this ferrite core, and the nonlinear winding translates into a linear change in frequency. And Collins states that you get exactly 10 turns end to end, and that you get perfect linearity, though that's probably an advertising term. But so what's inside here is actually not real complicated, I guess, but was pretty much like a proprietary product that nobody else has duplicated. And to this day, I don't know if anybody else knows the formula for, what's the actual mix that they use for the ferrite. But
And winding those windings, they had to be in precise location. Oh my God.
They didn't have computer aided design or anything either. It was all done by, slide rule, I guess.
yeah, slide rule, then build it and see what happens.
Yeah, I bet they built several prototypes, I'm guessing, before they got it where they wanted it.
Well,
I would think so.
Did they make the ferrite? Is that what was proprietary about this? Otherwise, somebody else could have copied it if it was a common part.
But nobody did copy it, I guess. And I think another point here is that in ham radio equipment, I don't know of anybody else that used a permeability tuned oscillator. And these appear in pretty much every Collins radio from this World War II.
Pat, from the time frame, they might have been able to develop that PTO. That could have been developed under a wartime contract with beaucoup federal dollars. I don't really know the answer to that, but I know who I could ask. K0DAS might know the answer to that.
Sure.
This is Tom, W9IPR.
Go ahead, Tom.
I went to college in 1955 at K-State in Manhattan. And in 54, I used to talk to a guy in Manhattan who had Collins equipment. And he up through the kilowatt, the big kilowatt. And what fascinated me so much is that my family had a grocery store and meat market. This guy with the Collins equipment had a wife and two small kids and a grocery store meat market, which was attached to his home in Manhattan. And I just marveled because indeed, in 1955, there was nothing like Collins. It was the ultimate. And for that reason, I suppose, in 60, I ended up interviewing Collins and did get an offer into their QA department, which I didn't take because I was looking for rockets and stuff like that. But Collins was the ultimate piece of equipment in the 50s. And they also, Curtis LeMay also is the one who introduced single sideband to the Air Force initially. And it was bought then by the Air Force, and that's what got single sideband going. They were undoubtedly the epitome of both military and then commercial amateur radio equipment. And just to go to their plant, it was in Cedar Rapids, just to go there and look around and be a part of Collins, so to speak, was quite a thrill at the time. But so be it.
Okay. Well, thank you, Tom.
This is Carl. This really comes from an age of really elegant engineering.
Mm-hmm.
I worked for Hewlett Packard for 22 years, and I got to know people who had maintained old equipment for Hewlett Packard in a corporate museum. And you look at this stuff that was designed in the 30s and 40s, it's a real mixture of not just elegant vacuum tube technology, but mechanical technology too. You know, you look at as people were noting about the coils and how they're wound. I mean, there's an art to this stuff that you don't see anymore. People just do everything digitally these days, which is great and it works even better. But to go back to those early days, it was a really very artful approach to engineering that took mechanical knowledge, electronic knowledge, and a little bit of art thrown in too. It's really incredible stuff. When you look at the old HP equipment, this Collins equipment, all top of the line stuff, you know. And I hope it never goes, Pat, I hope it never goes to the recycling bin. This stuff should be maintained for many years to come because it's a piece of museum quality equipment.
Yes.
Even tubes had curves.
Mhm.
You better believe it. And kept you warm too.
Okay. Well, I think we're running kind of late here. It's about 8:30. If anybody would still has questions or would like to talk some more, we can pick up the discussion after the meeting.
That'd be great because there's more PTOs out there than you think. So
Okay.
let's meet afterwards, okay?